let's start. Hello, everybody. So we're here to talk about DEPC, which is a tool made in OVH to compute the QoS of our customers and our architecture. So I'm Nicolas Croquefer. I present you Anthony Olea. We are two Python developers in OVH, and we built DEPC. First of all, the good news, the project has been released this week on GitHub for the FOSDEM, so you can retrieve it using this URL on the OVH account. Don't hesitate to take a look, give us your feedback, and if you want, we can improve it using it. So during the next 25 minutes, we are going to explain you the objectives of the project, why we decided to build the DEPC. Then we'll talk about why we need a graph dependency in this project and what is the link between computing a QoS. Then the most interesting part for you as Python developer will be how can we compute the QoS our customers using different methods like the raw QoS, the operation QoS, and the aggregation QoS. And to finish, we'll see how we can use Airflow to schedule tasks every night and compute the QoS for our customers each day. So first part, the objectives. Anthony and I are Python developers in the web hosting team of OVH, a French cloud provider. And our team manages around 5 million websites, which are distributing between around 14,000 servers. Most of the case, everything is okay, of course, but sometimes we can have a crash of one or more services, and even if we have some load balance systems, maybe sometimes some users can be impacted. So the objective of the project is simple. We need to compute the QoS, so the quality of service, of every website, of all the 5 million websites. The quality of service is QoS is a simple percentage, which saying if 100% everything is okay, it's not the case, it's not okay. It's not enough. In case of bad QoS for a particular day, we also need to find the root causes of the root case. So we need to find what servers, between these 14,000 servers, have impacted my customers and why. So it's the objective, and the next part presented by Anthony will present it, will be around the graph part of the project.
Okay. So the first thought for the project was to get the HTTP status code of every website hosted by OVH, but it's a bit complicated. It's not really handy. And sometimes it's even the customer's code which is not working, so it's not our infrastructure. And of course, in DEPC, as Nicolas told, we want to know the root causes. So the idea of DEPC is to use dependency graph to find the root causes. For example, .com, we can imagine this kind of architecture. When the old nodes are working fine, the website is up. But if a website, if the DBS is not working anymore, the database is not working, and the website will be down. So we can both find the root causes and also get a QoS for example.com. In order to get a graph in DEPC, we are using Neo4j, which is a graph-oriented database. And we are using Kafka, which is a queue, in order to handle the messages, especially for the web hosting team. We populate the graph in real time. We have orders constantly, and the infrastructure is moving. So we have a Python consumer, which is currently handling messages, and which is validate and reformat the message in order to populate the Neo4j database. With this kind of graph. We have currently millions of nodes and relationships in DEPC, and it is growing. So this time it's about the rule QoS.
Thank you. Okay, so Anthony explained why we need a graph dependency in the DEPC project, and how we can handle the messages and transform it in nodes in Neo4j. Now you can ask us what is the link between a graph dependency and the QoS? How to compute a QoS from some nodes in our Neo4j database? In fact, there is two cases. We have lots of nodes in our Neo4j, and for certain nodes, we have probes that are running and checking something like the CPU, like the RAM, like the ping, the response time from the ping. Lots of things to check and to see if server, so the node, is okay. These things are sent to time series database. So we have graph like, I present it later, sorry. So you already know what is the time series databases. We can have some information about metrics to see if our servers are okay or not. It's the first case, and we will see together how we can use world QoS for it. Another case is the node cannot be monitored. For example, a website cannot be monitored by a probe checking the HTTP static code, because we cannot guarantee the code. Maybe the user itself can raise an error. So in this case, we will not use time series database, but we'll use its own parent QoS to build its QoS. In this case, we are talking about operation QoS and aggregation QoS. So let's start with the world QoS and using this simple schema. We want to compute the QoS of the website here, which depends on just two dependencies, which are a storage server and a web server. Next, we'll see that we also want to compute the QoS of a group of websites using a label named offer. We are talking about the filer part using a world QoS. It's the graph I wanted to show you before. You know it, it's a Grafana picture showing some dashboards taken from the official website. And the idea of the world QoS is really simple. We need to analyze some data points, and for example, if these data points are above a given threshold, we can say during this moment the QoS is not given for our user, so we are going to decrease the QoS. Here is for a server named filer01. It's the response time for the ping, and we can see there is two problems. Here, it's a representation of some data points. Of course, we are computing the QoS every day, so there is just small, a few, I say 10 data points, but there is lots of data points in one day. And we can see for 6 data points, the QoS, the response time is above a certain threshold, so the QoS must decrease during this time. We can have another type of check between the interval, and it's the same method, but we also analyze a bottom threshold. So the idea, we'll see some Python code. The idea is to convert the previous picture, which is time series containing values, into a time series containing Boolean value. So just two values, true, false, and I don't know if it, yes. Here, when I have a problem, I transform it into false values. How to do it? It's the table representation, not really interesting, but you can see we transform some values into Boolean representation. And it's the module we use. Certainly you know Panda, it's a module to analyze and manipulate some data using some data structures like series and data frames. And here, we can use it to simply transform. It's the first step. We also show you some other steps later. The first step is to transform, you can see over there, a dictionary of timestamp values. In the case, it's timestamps. In the values, it's the response time of the ping. We transform it in Boolean values, just by here transforming the data points into series, a Panda series. And then we apply for each data, we apply a simple function. Here is just a lambda saying everything that is above the given threshold is 20. will be converted into false values. So we transform Booleans, time series values into Booleans values. Okay. And it is the result. You can see in the picture of DEPC, we analyzed a metric in time series database and convert it into a QS. So here you can say me, I just have Booleans data and it's not a QS, it's not a float number, and how can we transform it in this kind of number? Anthony will just show you how to do it.
Okay, thanks. So in order to get a QS, we have several steps. First of all, just imagine the website. We don't have metrics actually. We have metrics for Filer, Apache, but we don't have metrics for our website. But we want the QS because it's a customer website. So the QS of the website is a combined between the QS on the Filer and the Apache. Here is the AND operation between both of them. So when the dependency is not working, one of them is not working, the website will be done. We have the Booleans for the Filer, the Apache, but we can compute the Booleans for the example.com like that. So in Pandas, we have the two series for the Filer and the Apache, and we want to merge the two series into a data frame. Just consider this subset of data. We don't have the same timestamps for the values, so when we merge the both series, there are some gaps. Here with the non-value. So, because the probes are not sending the metrics in the same time, so it's really a real-life example, actually. We don't want gaps. In DEPC, we are applying a forward-filling and back-filling operation between the rows. And as you can see, in the previous table, you have an AND value, and here we just put the false in the next rows. And when we have a NaN in the first rows, we can put with the backfill operation the true here. Then we don't have any more gaps, it's good. And we can apply the AND operation between the columns. And we can have this result for example.com. So in Pandas, you have a data frame with full rows with no gaps and the AND operation. Now we want to just keep the changing state actually because this is just true and false, so we can just reduce the amount of data, especially for next computation. I will speak about that later. And in order to compute the QS, we want the duration. So we apply a group by operation and the sum, and we can get the duration for both false and true. It's a very small subset here, but in DEPC we mostly compute for 20 hours. So now with the true period and then with the total of the periods, we can compute the QS, the real deal. And
excuse me, just a note, before, just a few minutes ago, I talked about the whole QoS, and we just finished showing a Booleans time series, and what is the link between a Booleans time series and a real QoS. Anthony just showed it. In fact, when you want to check the QoS of a server, you don't just check the ping like we show. You also check lots of other things. And in this case, you can have lots of metrics. You can transform all of these metrics between in Booleans metric, and then apply a hen, for example, on it. And in this case, it's the exact same algorithm we applied to compute a QoS for a whole QoS. Sorry.
Okay, so we have also the orb operation available in DEPC, and the ratio and the at least operation. Now the aggregation QoS is for the offer, because sometimes we don't want the end or the or, the at least, and the other operation that showed you. We want the average operation, for example. There is no value if a website for the premium offer is done, all the website for the premium offer should be done. It's not really relevant. So we can compute the average for the nodes and also the mean and the max for the nodes. That's for offer, it's very useful. Now I will let Nicolas to talk about Airflow.
Okay, so we've seen together how we can push data into a graph databases, and how we can compute the QoS for each of the nodes, depending of if the node has data to analyze in time series database or not, and in this case we analyze its parent QoS. Now it's time to assemble all of it and use a scheduler to compute the QoS of our customers every night, because in OVH and in the web hosting team, we compute the QoS for each day. And so we use Airflow as the scheduler. Airflow is a task scheduler. It's like a cron++, written in Python and made by Airbnb. It's now in the Apache Foundation. And it's a workflow or pipeline, if you prefer. It manages some dependencies. So you can view to the right of the screen here. We have some task to be done before some other task. And we can also have some task running in parallel. And this task is waiting the result of the other task. The best practice is to have idempotent task. So here is the web server of Airflow. Why we decided to use Airflow to build our QoS is for many reasons, and the features of Airflow, which is if any task fails for a reason or another, we can fix the problem and retry it using a CLI or using the web server. We can also have access to this great web UI and have the logs of everything, because during the night we sleep, of course. Excuse me? No, not yet. We do not have a on-call, but we hope to have it. Excuse me? Yeah, of course, I don't sleep. So, okay. How Airflow can know the task to launch, and if sometimes he must to launch role QoS, or sometimes he must to launch operation QoS or aggregation. In fact, it's the user which tell to DEPC how to do it, using this simple JSON configuration. So in the interface of web UI, or using the API, the user telling us he need to use world QoS for Apache and Filer, an aggregation for the offer, and an operation for the website using the Filer and Apache nodes. It's the web UI representation. And to finish, just a few notes about how to create a DAG in Airflow. A DAG is a group of tasks which will be done the one after the other. Here, it's really a simple DAG. If you want to have the complete code, of course, you can go to the GitHub repository and see the /scheduler folder. Here, we just declare a DAG. The owner is DEPC. And the start date is 1st of the year. So if I launch Airflow today, Airflow will fill back every task for every day until the 1st January. Then I declare my DAG here, naming Compute Acme QoS. And here, I think you recognize it. It's a cron format. to say my DAG must be launched every night at this hour, 1 hour and 15 minutes. Here, it's not really important, it's just an example of some task, but in the repository of GitHub you can see the complete code. It's for a compute rule QoS, operation QoS, and aggregation QoS. And here, if it's okay, yeah. Here, it's the interesting part of how to create a DAG using Airflow. Over there, here, I create 4 tasks for my, my 4 labels. So Apache, Filer, website, and offer. And over there, I create a Python operator. In fact, when you use Airflow, you can want to launch tasks doing some jobs. For example, you can want to launch a bash script. You can want to send a mail to happen a row in a database. And for each kind of need, Airflow provides us an operator. In our case, in DEPC, we just use the Python operator. You can see over there. I create my task here using the Python operator, and Python operator provides me an attribute named Python callable. In this case, the Python callable here is compute rule, operation, and aggregation. Okay? A cool feature of Airflow is that DAG can be created dynamically using Python code. So here, it's sort of static because I created the Python callable, the compute rule, etc. Let's imagine that Airflow parse our code, our DEPC code, using Airflow, parse the user configuration and create dynamically this code. And to finish here, it's how we can say to Airflow the order of the task. We can see here, these 2 tasks will be launched together. So in parallel, using some worker, for example. And once they will be done, the website task can be launched. And then, after the website task, it will be the offer task. Here we use some bitwise operators, but you can also use some methods like set upstream or set downstream. And the result in DEPC is the following. You can see over there, it's the Airflow interface. And here we see our DAG using 4 tasks, Apache, Filer, website, and offer. And the DAG is launched every night for every team. Here is just for the Hack.Me team. But we have the web hosting team, we have the storage team, etc. in OVH. And each of the team has its own DAG. And here it's the result of the DEPC interface displaying the QoS, the evolution of the QoS of the filer of the Apache, etc. So we are done with DEPC. And if you have any question, we'll answer it with pleasure. Thank you.